Hello everyone. On this video we are talking about measuring areas for the different quadrilateral shapes. Now we already discussed what is a polygon and what is a quadrilateral. A polygon is a shape which is enclosed by all its sides, and a quadrilateral is a special type of polygon which is enclosed by four sides. So rectangle will become one kind of quadrilateral. The same is the square, and we'll discuss two more. One is parallelogram and another one is trapezium. Now the first things come to your mind is, why do you really need to measure the area? Now let's consider these things, that we have walls, lawns, garden. Now how do you quantify that this wall is bigger, or this lawn is bigger than another lawn, or this field is bigger than? So for that we need a number, and we quantify them with the help of their areas. Now let's consider the area of a rectangle. How do you find the area of a rectangle? Now how do you first measure a quantity? Let's say kilogram, grams. How do you measure it? We consider a standard quantity first and then say that the other one, like we first define a standard unit for it. Now in the case of the area, the standard unit will become a square unit. And then we say that this rectangle is n times, or the number times of square unit. Let's consider that it's coming up to be little. Not properly. Give me a second. Area. Okay. So now let's start again. So let's consider that this is one square unit, and we need to find what is the area of this rectangle. Let's call this rectangle as rectangle A, B, C and D. So if we need to find the area of this rectangle, let's just count how many these small or a standard square units are fitted in this rectangle. So it's 1, and say it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh yeah, we reached it. It's 15. Now, if we see that there will be a pattern generated where you can say that this, the side of this is 3, and the side of this, that is the column, there are 3 columns in it and 5 rows in it. Oh sorry, the other way around. There are 3 rows in it and the 5 columns in it. So we can easily say that the next time you don't need to count it, but you can just say that it is a product of the dimensions. The dimension, what is a dimension? The sides. It's the product of the base, which is DC, and the altitude or the height, that is AD. So we can say that the area of this rectangle is 15 square unit, and if the unit is feet, then we can say it's square feet. If it's in meter, we say it's 15 squares meter. So these are the squares. There are 15 squares in it. Though the length, we measure it as 3 feet or 4 feet or 4 meters, but when it comes to the area, it is the number of squares. So we write it as 15 square feet or 15 square units, whatever be the unit of your sides or the dimensions. So I'll reiterate again, is the rectangle. When we goes to the rectangle, how we actually, we all have learned the formula. We know the formula that it is the length into the breadth. Length into the breadth or the product of the dimension, but many of us still are not able to relate that why it is length into the breadth. It explains here why it is length into the breadth. Here we have a length and we have the breadth, and we are dividing it into the square units. So the number or whatever is the length, that many rows we'll be having, that many squares of rows we'll be having, and the number what is defined by the base or the breadth, that many columns will be having, or that many square columns will be having. And when we multiply both of them, we get 15 square unit, which we have got from counting these squares. So this was all about how do we find the area of a rectangle. Now let's go to the area of the square. So what is a square? A square or a perfect square is a rectangle in which your length as well as your breadth, or your height as well as your base, both have the same dimension unit. So here we say that again it's the same. The area of this will be length into the breadth, because it's just a special case of a rectangle, which will in turn be 3 cross 3, that is 9 square unit. Or if it is in meters, you can say, if it's 3 meters, you can say square meter. If you count here 1 2 3 4 5 6 7 8 9, so there are 9 such squares, so this will come to be 9 square meter, which again is very simple. The length AD to the breadth CD, or you can call it as a base, you can call it as a, and this one you can call it as an altitude, or you can just say the product of its dimensions. Now let's go to another kind of a polygon and a special rectangle. Special quadrilateral, and a different kind of a quadrilateral. That's a parallelogram. Now let's call it the parallelogram as parallelogram A, B, C, and D. So how do we find the area of this parallelogram? For an ease, what I'm trying to do is I'm just cutting this little triangle from here and trying to place this little triangle here. So let's call this as another point as P, and this will are D, B. Now if you see that this has become again a rectangle, I have just cut this part. I've just cut this part and stick it around here. There will be no change in the area because the number of square units which are enclosed in it will still remain same, because I'm not changing any dimension. I'm just cutting this piece of paper or piece from here and sticking it around here. That will give me this kind of figure, which is again a rectangle. Now what's the area of a rectangle? If I call this point as a Q, then the area of this rectangle will become the length. What is the length here? The length is this TQ into the breadth. The breadth will become this PC or AB, the breadth. So it will, let's just put small b to avoid a confusion. So it's still here, completely till here. Okay, so what will be the area of this parallelogram? I'll repeat again. I have just cut this piece and put it here, and now I'm trying to see the area of rectangle ABC P. A, B, C, P. If the area of the rectangle ABCP is same as AP into the length of AP into the length of AB. Now we can say that AP is same as QD. So I can just say it's QD into AB. That will give me the rectangle, the formula for the area of a parallelogram, or sorry, the area of the rectangle. Then will come, it would be the same as the parallelogram, but let's come to that later. So here, this will become as length into breadth. Let's give some units to it. So this will be 3, and let's give some unit to it. So it's 5. So that's again become 15. Now, forget about this picture for some time. If you are just given a parallelogram, then the length of this parallelogram will, then this area of this parallelogram will be same as 15 square units. Why? Because you can just cut down this, put it over here, and then use the same formula for the rectangle as length into breadth, which is the length will become your this, which is QD, and the breadth will become as AB. Now let's find the area of one more quadrilateral, and that is a trapezoid. Let's consider this as A, B, C, and D. The easiest method to find the formula for the trapezoid is, let's duplicate it. So here we have our first trapezoid, and I have just flipped it around, the same size of trapezoid. Stick next to it. Let's call it again as A, B, Q, R, S, or let's stick it to what it was. So this will become RC. Please consider it as a straight line, and this again as T. So now, what is this 2? The area of the trapezoid, second trapezoid, is same as that of the first one. I have just flipped it around. If you can see that this figure AQRD, the figure AQRD is a parallelogram. So what would be the area of this figure AQRD? The area of the AQRD parallelogram would be, as we discussed earlier, which is the length, that is the altitude, and the breadth. So here let's consider the altitude as AM, so it would be the length or the altitude AM, the breadth DR. So that would be again the length into breadth, which will again be AM into DR. Now again, to repeat here, we are talking about still the parallelogram. So this would be the area of the parallelogram AQRD. AQRD. Now AM, let's keep it as AM. What is DR? Can I say DR is DM plus MC plus CR? Or in other words, is it possible for me to say that the DC, it's DC plus CR, where CR is equal to AB. So it is DC plus AB. As they are both the same trapezoid, the length of CR will be the same as length of AB. That gives me the altitude, the length of this altitude AM into, if I consider this as a B, then this becomes as my B, AB, and if I consider this as B dash, this becomes my B dash. Now still remember here, we are still talking about parallelogram. So when it comes to a trapezoid, this parallelogram is made up of two trapezoids, 1 and 2, which are of same equal area. So the area of the trapezoid, I am lacking the space here, but I can just say that the area of the trapezoid will become as half of B plus B dash into L. Half of this. Am I clear with that? Thank you.